Hello, welcome back to our channel. I am Anisha, a maths faculty for class 12. We have started chapter number 5, Continuity and Differentiability of class 12 NCERT book. In this videos, we are doing questions of exercise 5.1 and we have completed up to question 24. In this video, we're going to do question number 25 of this exercise 5.1 of chapter 5, Continuity and Differentiability. Let's move to our question. Okay, so let's read the question first carefully. So what we have to do in this question, we have to examine the continuity of f where our f is defined like this. Okay, we have our function f which is defined like that, and we have to like examine the continuity of a function. So what we mean by a continuous function? Continuous function, that means the function should be continuous at each and every point of its domain. So as you can see, the function is defined for all elements for any real number. So here our domain is whole R. Okay, so as you can see, our function is defined as sin x minus cos x if x is not equals to 0 and minus 1 if x is equals to 0. And a lot of time I have said you, when you have a function like that which is splitting in like cases at a particular point, what you have to do, divide it in cases, check the continuity in both the cases differently, then like make your conclusion. So what will be our first case here? Case 1, when like we are doing, what we are going to do, we will like check the continuity of the function at each and every point of the domain. So for case 1, when your x is not equals to 0, take your x as some say x equals to c, which is not equals to 0. Now we're gonna you check the continuity of a function. As you like till now you have seen I think in like previous video of question number I think 23 and 24, I also shared you that trigonometric functions are continuous in their domain. So in particular, we have started with the very basic trigonometric functions that are nothing but sine and cos functions. So like what I'm trying to say is that sine and cos functions are continuous in their domain, and we know that the domain of the sine and cos is nothing but whole R. So by this we can like easily say that the sine function and cos functions are continuous in its domain. That means for all x not equals to 0 also it will be continuous because its domain is whole R. Then we can easily use the like algebra of continuity. Okay, I just said the things orally. Let me explain you how I'm like trying to explain you. So we know that if I like I will say you that my sine and cos functions are continuous. You know that also. Or if I make the graph, if I make the graph of this is my sine x graph, right? This is pi by 2, pi minus pi by 2 and minus pi. So we know that the graph goes like this and this. As you can see, the graph is like continuous graph. So we like graphical approach is also there. When you do not have to lift your pen at any point at a particular at any point, then the function is said to be continuous. So similarly, as sin x is a continuous function, similarly our cos x is also a continuous function. So our sin x and cos x are continuous functions. What do you mean by continuous function? That means continuous in its whole domain. That means they are continuous on whole R. Okay, now we're gonna use the algebra of continuity. What is algebra of continuity? I'm writing like the work we want, I am writing here. Then we will use it directly here. So what do we use? Algebra of continuity. So here what we use, since sine x and cos x are continuous for any x belongs to real, then by using algebra of continuity we have sin x minus cos x is also continuous at x equals to our x, oh sorry, at x, which like for which we have started. Like if I take a fixed point, suppose for x equals to c, the function sin x and cos x are continuous. So sin x minus cos x is also continuous at x equals to c. It's just algebra, like the sum of two continuous functions is continuous, product of two continuous function is continuous, subtraction of two continuous functions is continuous. So by this, what we have, that our sin x and cos x is continuous. Or like if you want to check it also while using definition, you can, like I will give you a hint. You, instead of taking a limit x tends to 0, I'm just giving a hint for you. Like now you can, it's very like very fine that you can directly use that the sin x and cos x functions are continuous functions. But if you like in your question where you are writing this answer, like it is specifically asking you to write it clearly, like explain why sin x and cos x are also continuous. So you can use this limit x tends to 0, sin x minus cos x. This limit can be written as limit x tends to c. Okay, I will write it clearly here. So what I'm doing, I'm rubbing this graph so that I can write it clearly. Now you get by this graph what we have shown, that the sin x and cos x graphs are smooth, so therefore that's why they are continuous. But I'm giving you the limit definition that for any limit x tends to c, sin x minus cos x can be written as limit h tends to 0, sin c plus h plus cos c plus h, where h is, so this limit is very easy to find. Just use like a algebra, like a sin a plus b is nothing but sin a sin b cos b plus sin like cos a sin b. You can just use like a sin a plus b formula and cos a plus b formula, and you can easily find this limit. Okay, this will be nothing but sin c plus cos c. Okay, I have given you both the ways. Now let's move to our work. Okay, so for case one, what we are taking, that x equals to c, the function is continuous. Like I have already tell you that this limit is like this sin x and cos x are continuous functions. So by this, our function is defined, right, for x not equals to 0, because sin x and cos x are defined for any real. So function is defined and its limit value, limit x tends to c, sin x minus cos x. This limit will be nothing but sin c cos c minus cos c, which is nothing but our function value, that is f of c. So therefore, the function f is continuous for all x not equals to 0. Continuous for any x not equals to 0. Now let's move to case 2. What is case 2? When my x is equals to 0. Okay, when my x is equals to 0. Now as you can see, when your x is equals to 0, your function value is defined as -1. Now what we want for the continuous, its function value should be equals to its limit value. So for limit value, let's find its limit. So its limit will be limit x tends to 0, function f of x, and we know that for x, like here we are like approaching to 0, so like it will not take the function value where x is exactly 0. So our function value here will be sin x minus cos x. So this limit will be limit x tends to 0, sin x minus cos x, and we know that this is a continuous function, limit always exists. Its limit is nothing but sin 0 minus cos 0, and we know that sin 0 is 0, cos 0 is -1, so this will be -1. As you can see, limit value and function value is same. So by this, f is continuous at x equals to 0 also. So from case 1 and case 2, what we conclude? Our conclusion is f is continuous for any x belongs to real, that is nothing but our whole domain. So by this, what we conclude, that f is a continuous function. That's what we have to do. Okay, so we are done with our question. I hope you understand this. What I'm trying to say, like whenever you have a like trigonometric function, you can directly use that like they are continuous in their domain. If like in the question you have not specifically asking to prove that also. Otherwise, you can use them directly. And in like questions, this trigonometric functions are very useful. That they like it's very useful you to know that they are continuous, so that you can use, as I have used here also, like algebra. So Okay, sorry, algebra, so so that you can easily apply that algebra of continuity and use where you want to check the continuity of the function. Okay, so that's all for today's video. I hope there is no doubt in this question, but if you have any doubt, you can ask me in the comment section. And that's all for today. Thank you. Please like, share, and subscribe.